So 3.6 is direct variation. Let's chat about it. We're going to recognize and write when quantities are directly varying, and write equations for linear functions that do not supply an initial value. And we're going to describe a solution that means and what it means in the context of a situation. That is just reoccurring. Couple of recalls. First, the constant change. So it looks like we're going to look at these linear functions, hence this whole unit. And I want to remind you that the ratio of change in the response to the change in the explanatory variable, that ratio is the change. Response is usually called y in your calculator, and the explanatory is usually called x. Okay, as a general statement, but I really, the only reason I'm even putting them here is because of calculator business. But in general, I feel like we can use variables that are so much more representative of the situation. It's like calling something a better name. We have a pretty good vocabulary. The change, remember, is just the difference. So I'm reminding you of how they created the slope formula, right? That we know so well. Or we've seen. Maybe we don't know it very well, but we've seen it a ton of times. Okay, so nonetheless, that constant rate of change is the ratio of how much is the response changing compared to how much is the explanatory variable changing. Also, I want you to remember or recall that y is equal to, what do they say, mx plus b, which again is the constant change times x plus the initial, and which sometimes instead of writing it in this order, we say, okay, it's the initial plus or minus, right, the constant change times the explanatory variable. Yeah? Okay. Example 1, the value of money. The exchange rate between $1 US and 1 Russian ruble is $1 for 62.32 rubles. Fill in the table and describe the exchanges of dollars and rubles. All right. So I just want to write down this ratio, right? So $1 is to 62.32 rubles. Got it. Okay. Well, $0, 0 rubles. $10, well, we would have to scale this up. If we have, for each one, we have 62, then for 10 of them, we have 620. So we have 623.2. Double that, and we would have 1,246.4 rubles. Okay, triple the one for 10, and we would have 1,869.6 rubles. Or you could just be multiplying these by how many. So if it's 1 for 62, then it's 30 for 1,869.6 rubles. Okay, by 40 would be 2,492.8 rubles, and then 50 would give us 3,116 rubles for 50 bucks. Okay, so here's our exchange, and it says, draw a graph based on your table. Label everything. Okay. Here we go. Let's work this out. We need up to 3,100 or 3,200. So let's see how much spacing we have. Because we always have to start at 0. Let's suppose I count by 500s. 500, 1,000. That would be 2,000, 3,000, 4,000, 5,000. Okay, that'll do. Let's use it. So we'll go 1,000 here. Yeah, sure. 2,000, 3,000. I counted by 500s. Yeah, whatever. I mean, you could have counted by something else too, but I think this works. And that means on our vertical, we're calling this how many rubles? And on our horizontal, we're calling this how many US dollars? And let's see, we have to go up to 50. If we count by 5s, is it okay? 5, 10, 15, 20, 30, 40, 50. Yes, okay. So let's go $10, $20, 30, 40, 50. Okay. I'm on it. Okay. $0, 0 rubles. And after 10, we are at 600. Well, that's halfway marker is 500. And halfway between that and 1,000 is 750. So it's below that, roughly there. I don't know. And at 20, we're at 1,200. So this would be 1,500. I'm going to put it right in the middle. At 30 US dollars, we're at 1,800. So this would be 1,500, and that would be 2,000. So something like that. At 40, we're at just under 2,500. That makes it so much easier. So this is 2,000, 2,500. It's really close. And then 50, 3,100. So this is 3,000. This is 3,500. So something like that. Okay, I see the line. Do I have a straight edge? No. Okay, so that means I'm going to go like this. Here is my handy new line maker. It's my ruler. Okay. Like that. Yay! Okay. So I see my line and draw the graph based on the table, label everything. Yes. And I also want you to notice that here's our line, and up here when it comes to the pattern, for every increase by 10, this did have a consistent increase. For each one, we went up by 62.32. And so the slope of this line should really be 62.32, FYI. But we increased it by 10 consistently. And so we really were doing this pattern. Okay, so consistent pattern over here and a consistent pattern of over here. But our real slope is 62.32 because the change in the response was always 623, but the change in the US dollars was an increase by 10. So 623.2 rubles for every 10 US dollars. In other words, that exchange rate. Got it. Okay. Find the slope of this linear situation. Oh, right. So I just said that was 623.2 rubles for each 10 US dollars, which is 62.32 rubles per dollar. Write what it means in the context of this situation. Well, each US dollar exchanges for 62.32 Russian rubles. Got it. What is the y-intercept of this line? Oh, I got to go back to the line. Whoop. Okay. Normally, y is the response variable, and that is this vertical. And so it hits or it intercepts that line at 0, right there in the corner. So this y-intercept is at 0. And what does it mean in the context of this situation? Well, if I go back here, also known as the initial value, yes? So this b was the y-intercept, and that's the initial. It means that you initially, if you have $0 US dollars, then you initially start at 0 Russian rubles. So that means 0 US dollars exchanges for 0 Russian rubles. Got it. Write an equation to describe the relationship between the US dollar and the Russian ruble. Okay, I'm on it. Well, this is what I would say. The number of Russian rubles is equal to, well, here's our constant change, but in reality, we said the slope was really this for each one of these, and we just scaled it up by 10 because we were exchanging 10 at a time. So our explanatory variable is our US dollars. Our initial was 0, and the exchange rate, or the constant increase, is 62.32 for each dollar. So here we go. Yes, is equal to 62.32 times the number of US dollars. Got it. A Big Mac is typically about $4. Man, I haven't had a Big Mac in a long time. How much does this cost in rubles? Well, that is US dollars, so that would cost about 249.28 rubles, or like 250, by the way. Yeah. Okay. Use your graphing calculator to verify the answers to number 1 and number 2. Okay, so the table and the graph. Write down the window you need to make it look like yours. Okay, so just so that we're crystal clear, in our calculator now, we are going to have to put that this is y and that this is x. Because it doesn't have rubles and it doesn't have US dollars, it has y's and x's. So, here we go. Y equals 62.32 times x. And I'm going to go ahead. First, I'm going to start with a standard zoom. So I went zoom 6. Oi, that is tough to read. And that definitely doesn't look like our image, which looks like this. It's very clear, crystal clear actually. Great picture. Does not look like that. So the first thing I'm going to look at is this. Our x values went from 0 up to, what is this, 60, 70, 75. From 0 to 75, or from 0 to 50 if we just want this snippet. So here we go. Second, oh no, you know what? No second, just window. X minimum, 0. X maximum, 50. Do we want it to scale by 1? We scaled by 10. Our Y minimum was 0. Our Y maximum was 3,000. And we scaled by 500. Graph. And voila. Ooh, that looks very similar to our graph. Okay, so use your graphing calculator to verify the answers to, well, first of all, our graph looks great. So we verified our answer to number 2. Write down the window. The window that we had was the X's went from 0 to 50. The Y's went from 0 to 3,000. We included our steps too, but nonetheless, it also said to verify number 1. Okay, well, back to the calculator. And I need to go second table. So these X's are going by 1 at a time because that's how I had it set. So second table set, start at 0 and increase by 10s. Now I'm going to go second table. And voila, we see that there's the calculator's table. And whoa, there's our table. Looking good. Looking perfect. Okay, so use your graphing calculator to verify your answers to number 1 and number 2. Write down the window you needed to use in order for it to look the same. Done. I think another thing would be that we also had to change the table set. So I'm just going to write that down too. We started at 0 and then changed it by 10. Okay. Quick remark. The equation of this line had an initial value of 0. And that is how we figure out if something has a direct variation, if we want to look at it by sight. But there's more here that I would like to write down. So when it comes to direct variation, this is what we have going on. This is when one quantity is proportional to another. Okay. So when one quantity is proportional to another, we can write the relationship. So between the two variables, as a linear equation. And that linear equation would be of the form go purple style. y equals kx. Because the initial is 0. So if it's proportional, then that initial value is always 0, and we would write it in this form. Okay. By the way, this is also phrased as also known as y varies directly with x. Okay, so here's what I mean. If we see some of these phrases, if we see the phrase one quantity is proportional to another, then we know we can write it in this type of relationship or generalize it to this linear equation. If we hear the words one variable varies directly with another variable, again, that's the same as being proportional, and it can be written in this form. One thing that I want to mention is that normally we write our lines y equals mx plus b, but if it's proportional, then this initial value is 0, and so this would just look like y equals mx. And that has just simply been rewritten with a k for a constant instead of an m. Okay, so when we know that this is happening, we just write it as y equals kx. But this is just a very, a special case of a general linear equation where the initial value is 0. Okay, and I want you to just think about this a little bit. That was kind of like the fact that these rubles, the number of rubles was proportionate to how many US dollars there were. And how when we set up our equation, our conversion was just this constant, and that constant was just our exchange rate or our conversion rate or our conversion ratio. So this K is really just, when we're converting, what is that conversion? If it's proportional, then we can do a direct conversion from one into the other. What would be that ratio that goes there? Okay? So in the next video, we're going to go through another situation where I believe this will happen.